2020 Canadian Open Mathematics Challenge, Part C. Find the areas of the three polygons described by the following conditions A, B, and C, respectively. So let's start with the first one, Part A. They're giving us that absolute value of x is less than or equal to 1, and the absolute value of y is less than or equal to 1. Okay? So, if the absolute value of x is less than or equal to 1, that means that if x is greater than 0, this becomes x is less than or equal to 1. And it means that if x is less than 0, then this becomes x minus x is less than or equal to 1, which is the equivalent of x being greater than or equal to negative 1. So combining this and this, x is less than or equal to 1 or greater than or equal to negative 1. All right? So in an almost pretty much identical way, this is the same. If y, absolute value of y is less than or equal to 1, that means that if y is greater than 0, you can put in greater than or equal to, just to make it complete. If it's greater than or equal to 0, that means that y is less than or equal to 1. If y is less than 0, then negative y is less than 1, and that means that y is greater than or equal to negative 1. So again, combining this and this, you get y is less than or equal to 1 or greater than or equal to negative 1. So pretty much the same thing, right? So now let's plot this. If we plot this on the xy axes, y is between 1 and negative 1, and sorry, that was x is between 1 and negative 1, and y is between 1 and negative 1. So that means that essentially we have this sort of area, this area right here. And the area that should be very easy to figure out. The distance from there to there is 2. The distance from there to there is 2. So it's essentially a 2 by 2 square. And the area is 4. Part B, the inequality x absolute value plus y absolute value is less than or equal to 10. Okay, so I'm going to need some space here. So this time we have absolute value of x plus absolute value of y is less than or equal to 10. Okay. So what are the scenarios here? Let's see here. The first one is when both of these are greater than or equal to 0. If that's the case, we have x plus y is less than or equal to 10. Correct? So that means that y is less than or equal to 10 minus x. Or if you really want, you can write it as minus x plus 10. Okay, the other scenario is when x is greater than or equal to 0, but y is less than 0. If that's the case, we have x minus y is less than or equal to 10, and therefore x minus 10 is less than or equal to y. So we're going to have to plot these. And then there's one more scenario, and that is when x is less than 0, but y is greater than or equal to 0. In that case, it's minus x plus y is less than or equal to 10, and therefore y is less than or equal to x plus 10. Okay, so, there's a fourth one. I can't believe I forgot about that one. That's when both of them are less than 0. X is less than 0, and y is less than 0. So that means minus x minus y is less than or equal to 10, and therefore minus x minus 10 is less than or equal to y. Okay, all right, finally. Now we can plot these. So again, let's see what we get. X, y, and here we go. So let's plot these one at a time. Let's plot the first one. Y is equal to minus x plus 10. So that means when x is 10, y is 0. When x is 0, y is 10. So it's basically, sorry, this is not going to be, beautifully drawn to scale, but hopefully you'll get the gist that that's that line, right? But we want y to be less than that. So that means we're looking at this sort of region. You see what I mean? Because this line is y is equal to minus x plus 10. But this is saying that y is less than or equal to. So it's essentially a region that anything below that line. Now we'll plot the next one, x minus 10. That is going to be basically a line that connects those 2 points. Sorry, this is certainly not drawn to scale, but you guys understand. So that line is y is equal to x minus 10. And again, y here is not just equal, it's greater than. So it's going to be that region right there. And in a very similar way, plot this one. Y is equal to x plus 10. And that's going to be this line right here. And of course, it's less than that, so it's going to be that region. And then finally, this one, minus x minus 10, is that line. And it's greater than that, so that region. So there we go. That is the graph. So to find the area, that should be pretty straightforward. Area, it looks to me like it's 4 times each triangle. And each triangle has the same dimensions, 1/2 base times height, where the base is 10 and the height is 10. Like that. So that looks like 2 times 100, so 200. There you go. That's the answer to part B. Okay, part C, the inequality x absolute value, y absolute value, x plus y absolute value less than 2020. So you have to pretty much proceed in a very similar way as the previous parts, and hopefully by now you guys kind of got a hang of it. You got to look at all the different scenarios and then plot each one and then figure out the area. Shouldn't be too bad. But I think this one's a little bit more complicated here. Okay, so we've got, I think, 6 different scenarios. 1, 2, 3, 4, 5, and then 6. And then I'll have to plot all my findings. And then, in the end, we will calculate the area. Okay, so the first scenario would be when both x is greater than or equal to 0 and y is greater than or equal to 0. So that would basically make this equation up here x plus y plus x plus y is less than or equal to 2020. And I'm going to always try to make it in terms of y. What I mean by that is, isolate in terms of y. So when I do, it'll be y is less than minus x plus 1010. Okay. And then I guess I can graph this. That means when x is 1010, y is 0. And then when y is 0, x is 1010. So up here. So you're connecting these 2 lines, and it's less than that, so it'll be this area right here. Well, it's more than that, but when I draw everything else, it'll be one confined shape. I don't know what that shape is just quite yet, but you kind of hopefully get the hang of this. Okay, second scenario, x being less than 0 and y is greater than or equal to 0. So that means, and then, then in these kinds of scenario, anytime you have something less than 0, we got to now also look at that. And this scenario, we will talk about when that x plus y is greater than 0. So this makes the equation minus x plus y plus x plus y is less than or equal to 2020. And isolating for y, we get y is less than 1010. Oh, okay, so that's just a horizontal line. So like this. Okay. So, all right. Moving right along. Next one, x less than 0, y is greater than equal to 0. Y is greater than or equal to 0. And then this time x plus y is less than or equal to 0. So notice here was greater than. So this becomes minus x plus y minus x minus y greater than or equal to 2020. And therefore x is greater than or equal to minus 1010. So that's just a line, a vertical line this time, minus 1010. And so like this. Okay, moving right along. Number 4, this is when they're both less than 0, y and x. That makes this minus x minus y minus x minus y less than 2020. And therefore, when you isolate for y, you get y is greater than or equal to minus x minus 110. And that would be y minus, so when x is 0, y is minus 10. So down here somewhere. And when x is minus 110, you get 0, so it'll be this line here. Okay, so let's just fill in. And I think we have 2 more, right? 5 and 6. All right, so scenario 5 is when x is greater than or equal to 0, y is less than 0, and x plus y is greater than or equal to 0. So that means that x minus y plus x plus y is less than or equal to 2020. And isolating for, well, y is canceled, so all we're left with is x is less than or equal to 1010. So that means that we've got this line. And then finally, the last one, x greater than equal to 0, y less than 0, and x plus y is less than 0. So that would make this x minus y minus x minus y less than or equal to 2020. That would mean y is greater than or equal to minus 1010. So you got this line right here. And there you go. There's the shape right there. After all that hard work. Okay, so now we're going to figure out the area. Well, this looks like a square that is 10 times 10. This also looks like a square with the same dimensions. So 10 times 10. And then, oops. And then these two triangles, they look like they have the same dimensions. So 2 times 1/2 base times height, where the base is 10 and the height is 10. So that looks to me like basically 3 of these guys, 3 times 10 squared, and that is going to be 3060300. So there you go. That's the area of that shape. An expression like x is equal to 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 is called a continued fraction. Write x given above as a reduced fraction of the form a over b, where a and b are positive integers. Okay, let me see if I can do that. So I have 1 plus 1 over 2 plus 1 over, so I got to add 3 plus 1 over 4. So that's going to be 12 over 4 plus 1, so it'll be 13 over 4. Okay. So now I've got to add these guys. I've got 1 plus 1 over, so I've got to add 2 plus 1 over 13 over 4. But before I do that, I'm going to flip that. It'll be 4 over 13 like that. Okay, now I can use my common denominator, and that'll be multiply top and bottom by 13. So it'll be 26 plus 4, which is 30. 30 over 13. Okay, so that would basically be 1 plus 13 over 30. And then getting a common denominator would be 30 plus 13 over 30. And that is 43 over 30. So 43 over 30 is basically my A over B, where A is 43 and B is 30. All right, moving right along. Write 355 as a continued fraction in the form A plus 1 over B plus 1 over C, where A, B, and C are positive integers. All right, so I think I'm just going to kind of copy the process of part A, but this time just going backwards. So I guess I'm starting with sort of a here and kind of just going backwards. So let's see if I can do that. 355 over 113, and then go backwards, and then eventually the hope is that I get something like that. Okay, so 355 is, I think, more than 3 times 113, right? So instead of putting a 1, I'm going to put a 3, because it's what, 3 times 113 is what, 339? Yeah. So plus some fraction here. So this is 339 over 113, and then if I took away 339 from 355, it would be 16 over 113. Yeah, that'll be fine. So I think this is promising. Okay, so I'm pretty much confident that that'll work. But then I've got to think about it, that I've gotten it down to sort of this part, right? But then to get to this, I've got to put it over 1. So I've got to do this 1 over, and then invert this 113 over 116. So now I've got it in this format. Okay. So as you can see, I'm just sort of retracing my steps. Now I've got to go to the next one. How do I do that? Okay. I guess I have to break up this guy. That guy I've got to break up into a number and a fraction. Okay. Well, how many times does 16 go into 113? 7 and some change, I think. So like 112 over 16 plus 1 over 16. Yeah. And 112 over 16, I believe, is 7. Yeah, because it'll be 80. Yeah, it's 7. So this is basically 1 over 7 plus 1 over 16. And I believe I'm done. Yeah, because this is of the form A plus 1 over B plus 1 over C. And in this case, my A is 3, my B is 7, and my C is 16. Okay, good. Part C says, let y equal 8 plus 1 over 8 plus 1 over 8 plus 1 over 8, ... Just kind of keeps going, where the process continues indefinitely. Given that y can be written in the form p plus root q, find the integers p and q. Okay. There's something very interesting here, that this guy is really y is equal to 8 plus 1 over this whole part is the exact same as y. It might take you a little bit of time to look at that to be convinced of that, but that's essentially what it is. And if you can get it into this form, then the question is easy. But I think getting it, recognizing that it can be written like that, is a little bit of a challenge. Okay, so now we really just have y is equal to 8 plus 1 over y, and this can easily be solved. Multiply through by y, you get y squared is equal to 8y plus 1. Put everything on one side, and when you do, you should get y squared minus 8y minus 1 is equal to 0. And I think this is going to be a quadratic. I don't think this factors. So we have y is equal to minus b, so that's going to be 8 plus or minus the square root of minus 8 squared minus 4ac all over 2a. So that means y is equal to 8 plus or minus 64 plus 4, so 68 all over 2. That is 8 plus or minus 2 root 17 all over 2. So that is y is equal to 4 plus or minus root 17. And let's see here. Y obviously has to be positive if you look up here. So therefore, I got it. Forget about all that positive, negative stuff. They're saying that it's equal to p plus root q. So therefore, since y is equal to p plus root q, we know that it will be 4 plus root 17. Okay. So that means p is 4 and q is 17. Three circles with radii 0 less than c less than b less than a are tangent to each other into a line as shown in the diagram below. Let radii a equal 16, b equal 4. Find the distance d between the points of tangency of these two circles on the line. Okay. I'm going to need to draw some lines, so I will draw one from this point directly like that across, and then one more line that goes from that same point but to that point right there. And I think that should be it for part A. Okay, let's label this now. The distance that they're really looking for is the distance from the two tangent points. So here's one tangent point and here's another. So that distance from there to there I will call d. And since this line is perpendicular, then that is d also. From here to here is d. And then this distance from here to here is a minus b. And this distance, the hypotenuse of that right triangle, is a plus b, or b plus a, because essentially it's just two radii. So now we just have a Pythagorean relationship that d squared plus a minus b squared is equal to a plus b squared. And the good news is that we have been given the values of a and b, but before I plug those in, I want to sort of get a general relationship. So we get d squared plus a squared minus 2ab plus b squared is equal to a squared plus 2ab plus b squared, right? So that means that d squared is equal to 4ab, and therefore d is equal to 2 root ab. So that's the general relationship. We'll circle that. And then now we can use a equals 16 and b equals 4 to get the value of d. So that means 2 root, what is that? 16 times 4. So that's 64. Square root of 64 is 8. So this is just 2 times 8. And therefore d is 16. Part B, a is 16 and b is 4. Find the radius c. Okay, so radius c. That's slightly different. All right, here, let's think about this. Okay, so I'm going to have to draw a couple more lines. Let me give a clean diagram here. Otherwise, this might get a little confusing. Okay, so in a very similar way, I'm going to draw a couple more lines to sort of make these into Pythagorean triangles. So the first one is a line that's straight across that goes through C, that circle. Alright, so with those two lines, we can now create a couple of Pythagorean relationships, since this is a right angle and that's a right angle. So this distance I will call x, this distance I will call y, and this distance here, it looks like that is b minus c, and then this distance here is a minus c. Yeah, a minus c. And then the hypotenuse are b plus c here and c plus a over here. Yeah, I think that's accurate. Okay, so now let's do the relationships. So from the first one, we have that b minus c squared plus x squared is equal to b plus c squared. So when we expand, we get b squared minus 2bc plus c squared plus x squared is equal to b squared plus 2bc plus c squared. And I think a lot cancels here. The only thing that we're left with is x squared is equal to 4bc, and therefore x is equal to 2 root bc. Okay, that's a pretty good relationship. And then in a very similar way, we do the other triangle, which would be y squared plus a minus c squared is equal to c plus a squared. And expanding that, we get y squared plus a squared minus 2ac plus c squared is equal to c squared plus 2ac plus a squared. Okay, so therefore y squared is equal to 4ac, y is equal to 2 root ac. Okay, great. So therefore, what do they want? They want the radius c. Huh. Okay. Okay, so that means, well, d is essentially x plus y, right? Because this is d. So d is x plus y. And when a is 16 and b is 4, we calculated d to be 16 in part A. So this is 16. And d is therefore x plus y. So 2 root bc plus 2 root ac, right? According to this and this. So therefore 8 is equal to root bc plus root ac. Now the values of a and b we are given as 4, so this is 4c under the square root, and this is 16c under the square root. So that means this is 2 root c plus 4 root c. So that means that is so that's what, 6 root c, right? 6 root c. So that means we have 8 over 6 is root c. And therefore c would be 64 over 36. And then in lowest terms, I think you can divide top and bottom by 4, 16 over 9. So c is 16 over 9. And finally, we have the configuration is called nice if a, b, and c are all integers. Among all nice configurations, find the smallest possible value of c. All right, so we had discovered previously some very important equations from parts A and B of this question. The first was that d was equal to 2 root a b, and that x is equal to 2 root bc, and that y is equal to 2 root ac, right? So since d is equal to x plus y, we can use these. So we got 2 root ab is equal to 2 root bc plus 2 root ac, like that. So I have ab is equal to bc plus ac. Okay, so now we can try to solve for c. Let's see here. I guess I can square both sides, and this becomes ab, and this will become bc plus 2 root bc root ac plus ac. And then this, not much we can do, but this can combine. We can write 2, the c's can combine to just give c, and then we'd have root ab plus ac, like that. And I think we can factor out a c from everything, so this will be b plus 2 root ab plus a, and therefore c would be ab over a plus b plus 2 root ab. And that's it. Okay, so now c is an integer, right? So since c is an integer, we have to make sure that everything is an integer. Okay, but the only way that's going to be an integer, if you look here, is if this root ab in the denominator is an integer, because everything else is fine. A and b are integers, but this guy is sort of the one that we have to really concentrate on. A times b under the square root sign must be an integer. So that basically means that both a and b have to be perfect squares. So we'll let a equal n squared and b equal m squared. If that's the case, then we can make this work. Once you substitute that in, c then becomes n squared times m squared over n squared plus m squared plus 2nm. Yeah. Okay, that's fine. N squared, m squared, not much we can do there, but the bottom, the denominator, factors very nicely into n plus m squared. And that is c. Okay, so what are we trying to find? The smallest possible value of c. Okay. You have to remember something that they gave us at the very beginning, that a is greater than b is greater than c is greater than 0. So we have to choose accordingly, because I think we're going to have to do some trial and error here. And if that's the case, then n is greater than m, greater than c, greater than 0. Yeah. Okay, so c has to be an integer. Okay. All right. So the smallest possible integers I could choose for n and m are 2 and 1. But then c would not be an integer, right? Because c's got to be less than 1 and greater than 0, and everything less than 1 and greater than 0 is a fraction. Well, let's just see what happens. Let's see what happens with this, and then we can try to extrapolate. Interesting question. Okay, so if that's the case, let's solve for c. C would therefore be 2 squared times 1 squared over 2 plus 1 all squared, and that is what? 4 over 9. Right, and as expected, that's not an integer. But if I made everything to the power of, not power, but if I multiplied everything by 9, then this fraction would disappear. I think I got it. Okay, so that means if you recall up here, we had called a equals n squared. So if a is 9 times n squared and b is 9 times m squared, I could get this fraction 4 over 9 to disappear. So that means I'll just keep with the smallest possible. 9 times 2 squared, so that's 36. And here 9 times 1 squared, so that would be 9. Okay. And then let's see what happens here. So I got to use this formula here, because this is the one with the a's and the b's. Okay, so this time c is going to be a times b, so 36 times 9. And then we got 36 plus 9 plus 2 times 36 times 9. Correct? So this looks like 324, and then when you do the bottom, you get 81, and that gives me 4. And there you go. That is indeed the smallest possible value for c. Let S equal 4, 8, 9, 16 be the set of integers of the form m to the power of k for integers mk greater than or equal to 2. For a positive integer n, let f at n denote the number of ways to write n as a sum of one or more distinct elements of S. For example, f at 5 is 0, since there are no ways to express 5 in this fashion. F at 17 is 1, since 17 equals 8 plus 9 is the only way to express 17. Prove that f at 30 is 0. All right. So first let's understand what what is it that this question is talking about? So what is S, first of all? S is the powers of mk, this guy right here. So powers of 2, powers of 3, powers of 4, and so on, powers of 5. So if you just list powers of 2, 2 to the power of 1 is 2, 2 to the power of 2 is 4, but you can't use 2 to the power of 1 because both the m and the k have to be greater than 2. So this guy you don't include. So the smallest is 2 to the power of 2, which is 4. Then 2 to the power of 3, which is 8. 2 to the power of 4, which is 16. 2 to the power of 5, which is 32, and so on. Then we use the next number, which is 3 for m. So m is 3. 3 to the power of 2 is 9. 3 to the power of 3 is 27, and so on. Then use powers of 4. 4 to the power of 2 is 16. That's already there. 4 to the power of 3 is 64, and so on. So as you can see, these are the numbers that you're going to use, and you can stick in like others. 5 to the power of 2 is 25, so that would go in here. And then 125. 6 to the power of 2 is 36. 7 to the power of 2 is 49. You get the idea. So that's how they're coming up with S. It's really just powers with that definition, m to the power of k, where m is k is greater than or equal to 2. And then they're saying that any of these numbers can be written as a sum of some of the elements. So they gave you an example that f at 17 is 1. The reason is because 17 is equal to 8 plus 9. Here's 8, here's 9. And the reason it's 1 is because there's only one way of doing this. There's only one way of making 17 equal to a sum of one or more distinct elements of S. Okay, so show that f at 30 is 0. All right. So that basically means that there's no way of writing f at 30. There's no way of writing 30 as a sum of one or more distinct elements of S. Let's see. Let's try to write 30 as a sum of one or more distinct elements. First of all, 30 by itself is nowhere in this list, so we can't use 30. But let's see. How about if I took this 4 and I tried to add something to it? 4. Well, I would need to add 26, but 26 is not in S. Okay? Let's keep going. Let's say I try to use 8. Well, 8 would need 22, and 22 is also not in S. How about if I chose that 9? 9, you would need a 21. 21 is also not in S. How about if I chose 16? 16, you'd need 14. 14 is also not in S. How about if I chose 25? You would need 25 plus 5. Well, 5 is also not in S. 27, you would need a 3. 3 is also not in S. And after that, that's it. You're done. Then you would end up with numbers greater than 30. And obviously, you can't add something to a number greater than 30 to get 30, since there's no negative numbers. So therefore, there is no way to write 30 as the sum of one or more distinct elements of S, and therefore f at 30 would therefore be equal to 0.